Have you ever stopped to wonder how your favorite streaming service just works, even when millions of people are watching at the same time? Or on the flip side, why a super hyped app sometimes just crashes and burns on launch day? Well, the answer to both is this invisible architecture called system design. And today, we're going to pull back the curtain on why it's the absolute backbone of the tech we rely on every single day.
Think about it like this. You wouldn't build a skyscraper without a detailed architectural plan, right? Of course not. And it's the exact same thing with software. Every single app on your phone, from social media to your banking app, is built on a blueprint that dictates how all its tiny little pieces are supposed to work together.
But what happens when that blueprint has a flaw? Or when it just wasn't designed for the real world? In tech, a weak foundation doesn't just lead to a few cracks. Oh no, it can lead to spectacular, very public meltdowns that affect millions of us all at once.
And to really get a feel for how high the stakes are, we don't have to look far. Let's dive into a couple of huge real-world examples where the blueprint itself was the root cause of a massive public failure. I'm sure you remember these, right? On the left, we've got Twitter's infamous fail whale. It became a meme, but it was basically a sign that the platform was just too popular for its own good. It couldn't handle the traffic. And on the right, the disastrous launch of Healthcare.gov, a system so tangled up that it just collapsed under the weight of even a few hundred people trying to use it at the same time. Both of these were massive failures, and both came down to system design. So let's zoom in on what actually went wrong with Twitter.
So if you look here, you can see the heart of Twitter's early problem. They started with what's called a monolithic architecture. You can just picture one giant, interconnected ball of code. The problem with that is, if one part gets overloaded, say from a single viral tweet, the entire system could go down. The fix? A total redesign. They broke that giant monolith into tons of smaller independent services. They split their single database into many smaller, more manageable pieces. That's called sharding. And they added caching, which is basically a way to keep popular stuff handy so you're not constantly bugging the database for it.
You know, Twitter's story isn't some unique, one-off thing. It's a perfect example of what we can call the architect's challenge. This constant struggle to design systems that can actually survive the insane demands of the modern internet. And the demands today are just staggering. We expect everything to be instantaneous. We expect our apps to be available all day, every day, and they have to process these mind-boggling amounts of data in real time. Without a really solid plan, that's just impossible. And that, right there, is the entire job of system design. It's the art and science of creating that master blueprint. It's about asking the big questions. What components do we need? How are they all going to talk to each other? And how do we piece it all together to build something that not only works on day one, but can handle the chaos the real world is going to throw at it? So what does a good blueprint even look like? Well, it's not about finding some single magic formula. Instead, great system design really rests on three core pillars that architects are constantly trying to balance. First up, reliability. This is pretty straightforward. The system needs to do what it's supposed to, even when things inevitably go wrong. Think about your banking app. A single transaction failing isn't just a minor bug, it's a huge deal. A reliable system is built to expect failures and handle them gracefully.
Number 2 is scalability. This is all about handling growth. What happens if your little app suddenly goes viral overnight? Can it handle 10 times the users? 100 times? Scalability is what ensures your system can grow to meet that demand without slowing to a crawl. It's exactly the problem Twitter had to solve.
And pillar number 3 is maintainability. Honestly, this one is all about making life easier for the actual humans who have to work on this thing. A well-designed system is clean, organized, and easy to understand, so engineers can jump in, fix bugs, and add new features for years to come without wanting to tear their hair out. Okay, so you might be thinking, great, reliability, scalability, maintainability, let's just do all three. Well, if only it were that easy. The truth is, it's often impossible. And that's because every single decision a system architect makes is about navigating a world of really complex trade-offs. And this right here is probably the most important lesson in all of system design. There is no such thing as a perfect solution. It doesn't exist. Every single choice is a trade-off. You are always giving up something to get something else. It is a constant balancing act. So let's look at a concrete example. One of the first huge questions any architect has to answer is, what kind of database are we going to use? And the two big families to choose from are SQL and NoSQL.
So, on the left, you have SQL databases. These guys are amazing for really structured data, where every little piece of information has to be perfectly consistent. Think bank transactions. Everything has to follow a strict set of rules. On the right, you've got NoSQL. These are way more flexible. They're perfect for stuff like social media profiles, where one user might list their job and another might not. But what's the trade-off? Well, you often sacrifice some of that strict consistency to get all that flexibility.
And that really just nails it, doesn't it? The goal of a great system designer isn't to find one magical, one-size-fits-all tool. The real skill is in understanding all of these trade-offs deeply and then picking the right combination of tools for the very specific job you're trying to do.
So why does any of this matter to you if you're not planning on becoming a software architect? Because honestly, understanding these ideas is about so much more than just technology. It's about how we build for the future.
It's a difference between just writing code and actually architecting a product's future. It's a strategic mindset. It's about thinking 5 steps ahead, predicting problems before they happen, and making smart choices that are going to pay off for years and years down the line.
And hey, don't just take my word for it. The industry is practically screaming for this skill. A whopping 40% of recruiters at the big tech companies, we're talking Google, Amazon, they prioritize system design skills in interviews. Why? Because it proves you can think about the big picture, not just the code right in front of you.
When you get it right, good system design is nothing less than a business superpower. It lets a company grow without going broke on expensive rewrites. It gives investors the confidence that you've got a plan for the future. It helps teams ship new features way faster, and it delivers that rock-solid reliability that we all just expect as customers now.
So I'm going to leave you with a little challenge. The next time an app on your phone freezes or a website is just painfully slow, don't just get frustrated. Take a second and ask yourself, what does the blueprint look like here? What trade-offs do I think the engineers made? Because when you start understanding the why behind the tech you use every day, you're taking the first step towards building a better one tomorrow. Thanks for tuning in.